to get too excited that this is going to be a talk about swimming with dolphins, saving the whales, or the discovery of a cuteness gene in this adorable baby sea lion. I should tell you that there's two very different kinds of marine biologists in the world. One kind spends their time triumphantly leaping off of boats with stylish wetsuits to try and study the charismatic animals like dolphins and whales. I affectionately call these marine biologists the dolphin huggers. The other kind of marine biologist studies the less charismatic animals in the ocean, like the worms, the slugs, and for me, the shrimp. And I don't just study any shrimp, I study 6 shrimp full of bacteria. This is the kind of marine biology that I do. In this experiment, I'm trying to measure the metabolism of a little sick shrimp, which is pointed out by that arrow. I made a flow-through respirometer from a bottle, and I'm measuring the changes in oxygen between the 2 electrodes. This is not triumphant. To do this kind of research, I need dedication and passion to working in obscurity. My research is basically invisible. I work on things that most people probably don't find that interesting and have a hard time relating to their everyday lives. And as a shrimp biologist, I'm keenly aware of how important big discoveries are in society. I remember how hard it was to tell my family after years of education that I would be studying shrimp disease instead of human disease. I think they purposely pretend not to tell their friends what I did for them. I spend my days measuring the metabolism, or the heart rate, or the blood pressure of a sick shrimp. How does this help society? Is this going to lead to a cure for cancer? Do shrimp even get cancer? All good questions. And if you have trouble understanding why be a shrimp biologist, or why small discoveries matter, you're probably not alone. Turns out there's a long history of minimizing the small discoveries. Going back to Sir Isaac Newton, and more recently Google Scholar, they all embrace this idea that we need to stand on the shoulder of giants to make progress. This is how we see further. And that idea that we need to stand on the shoulder of giants is quite an interesting way to think about this for shrimp biologists. There's not many giants in the shrimp biology world. Maybe a handful of scientists that are dedicated to working on shrimp, but no one's going to call them giants in any respect. But here's the thing. If you look at the major accomplishments that have led to the largest discoveries in human history, they're all based on the small ideas, the small discoveries. And this is what I think is important and kind of what I'm trying to get at, that these small discoveries lead way to the big ideas and the big contributions. So here's some examples. NASA estimates that it took the contributions of over 400,000 scientists and technicians and engineers to accomplish the moon landings. 400,000 small ideas and small discoveries. The Human Genome Project, which set out to identify all the genes that produce proteins in the human DNA. It took over 13 years, involved 6 countries and thousands of scientists. Even your iPhone, which hopefully you turned off, it's attributed usually to one person, but in reality, it took over 5 years to develop the first version, and the ideas and discoveries of thousands of designers and engineers. The small ideas, the small discoveries are what lead to the big advances and the big discoveries. I want to share with you a small idea I had about a sick shrimp. And this small idea, for some reason, became very popular and very visible. And when it did, it became kind of the icon for minimizing small ideas and discoveries as wasteful and unimportant. I think it's an interesting example of how uncomfortable we are when our small ideas become very visible and popular. We know that shrimp get sick despite having well-developed immune systems, that something in the environment is causing this, their immune systems to be unresponsive. What you're looking at is the gill of a sick shrimp. And all those little circles are the immune cells that should be fighting bacteria. We call those hemocytes. And what you see is that something is going on that's suppressing the immune system, and it's being overwhelmed by the bacteria. And we know this because those amine cells start clumping together, which is shown in that red circle, and forming aggregates. And this is a bad thing because when that happens, it clogs the blood flow through the gills, and so the shrimp has trouble getting oxygen. So imagine being a shrimp trying to fight disease, and they're basically suffocating at the same time. So my small idea was, that's interesting. I wonder what happens when these shrimp are active and are faced with fighting disease and they can't get oxygen. I needed to get the shrimp active in my lab. Shrimp are very active in nature. They're constantly moving, looking for habitats, feeding, trying to get away from predators. I needed to get them active in my lab. So my small idea was, I needed to build something to get them active. Maybe a treadmill would work. It was a weird idea, yes. So I decided to build a small shrimp treadmill. I didn't know if this was going to work, so I didn't spend a lot of money and time doing this. I used spare parts in my lab. The tread there is made from an inner tube off a truck tire. The bearings are off a skateboard. The motor is off an old car. I put the shrimp on a treadmill, and it worked great. I couldn't believe it. What a surprise. The shrimp would respond as the tread went faster, the shrimp would go faster, and so I could get the shrimp active in my lab. I wasn't trying to make the shrimp healthy, remember? I was trying to understand what was happening with the immune response. So I could compare sick shrimp to healthy shrimp, and this was a nice instrument to do that. And what I found was a big surprise, that the sick shrimp could perform, what you're seeing here, exactly the same as a healthy shrimp. That was bizarre. But what I also found was that the cost for that activity for the sick shrimp was much, much higher. The cost in terms of the energy to do the same exact activity, for the length of the recovery period after this activity, for the disruptions to the physiology were all much greater in the sick shrimp than the healthy shrimp. I had a small idea, I made a small discovery, and it would have ended there. This was part of a bigger project trying to understand disease and marine organisms, and so I went on to do my next experiment. What happened next, though, was kind of a surprise. Someone posted that video on YouTube without my knowledge, and it became very popular. For some reason, people wanted to watch a shrimp on a treadmill. They put up all kinds of versions of different music. They made the shrimp dance. Gecko was interested in doing a mock-up of a commercial where the gecko came down to tell the shrimp about cheap car insurance. I was invited onto the Today Show. I brought my shrimp and treadmill to New York City. I was on Talk Today. The video was featured on the Daily Show, the Colbert Report. And for the first time in my life, I felt like the marine biology gods were smiling down on me. They granted me dolphin hugger status. My mom and dad finally could tell their friends, yes, their son worked on shrimp. But remember, this was a small idea. I did not make a big discovery. I did not find some breakthrough in climate change or cure shrimp disease, but there was a lot of pressure for me to make this a big deal. I was getting calls from journalists and reporters wanting to know, get a headline, a big quote. And I kept trying to talk about those little cells and the clumping together and the changes of blood flow. And they wanted to know if I was developing a race of super shrimp that was going to take over the seafood buffets. If you've ever seen a teen coming of age movie, you know that things turn ugly when an unpopular geeky kid tries to hang out with an in crowd. This is what happened to me. I'm the geeky unpopular kid in the story. At some point in the movies, and this is usually around prom time, right? All the popular kids take their shot at sending the geek back to the minor leagues. And that's usually the lunch table for the unpopular kids in the cafeteria. And for me, there was no shortage of popular kids wanting to take their shot, making sure everyone knew this was a small idea, a small discovery. Everyone from congressmen to senators, to presidential candidates, to national associations and organizations, and entire TV networks, all wanted to make sure everyone knew this was a small idea. And to make their point, they said I had wasted millions of taxpayer dollars running shrimp on a treadmill. I even made the Forbes top 15 list of silliest uses of taxpayers' money. I think I came in at number 9, but it was before $3 million of taxpayer money I spent running a shrimp on a treadmill. I'm not sure where they got that number from, but it's a little discouraging. I can assure you that the government is not paying me millions of dollars to run shrimp on a treadmill. And while there has been a number of studies that have been supported to study disease in marine crustaceans, to me that kind of makes sense. This is a food item. They're certainly not spending millions of taxpayer dollars running shrimp on a treadmill. But I think it's important to realize how powerful this narrative is, that someone is doing small science and making small discoveries, and the taxpayers are paying for this. And we as a nation should not be supporting small ideas and small discoveries. We should be standing on the shoulder of giants. That's how we make progress, right? I was ready to crawl into a hole and never do shrimp biology again. What I learned from this experience was that how warped our perception of accomplishment really is. We should be celebrating all of our small ideas and all of our small accomplishments and all of our small discoveries for what they are, steps forward. This is how we make progress. And the danger of minimizing our small ideas, it really instills a sense of fear. Why even bother starting something if your small contributions are going to be seen as a failure or as wasteful? Stuart Firestein has a great book titled Failure, Why Science is So Successful. He makes a wonderful point where he says it is actually the failures, the missteps, the small, weird discoveries that we make that look like they're going nowhere that have led to the biggest accomplishments in science and technology. Everything from vaccines to antibiotics. So I think it's worth imagining if we took fear and failure out of the process for discovery, how much progress we can make. So I think it's time to change that narrative. I think it's time to start appreciating our small ideas and our small discoveries for what they are, and celebrating them as steps forward to making progress. I think we need to start praising our teachers in our classrooms that are trying new things, new pedagogy. That's how we're going to make progress in education. I think we need to appreciate our colleague who has a new idea or tries to go in a new direction, even if it fails miserably. This is how we're going to make progress in business and in technology. And of course, I think we need to thank and appreciate all of the wonderful dolphin huggers out there. They're the ones that are doing the research on marine mammals, and this is how we're going to make progress in saving the whales and our oceans.